Hello, today we discuss the project of Chen, Nahm, and Pin-wen Wang on content-aware image resizing. The traditional algorithms for image resizing are scaling and cropping. However, these algorithms remove or warp very important parts of an image. Content-aware image resizing finds unimportant parts of an image and resizes using those parts so as to not affect important content. How do we measure importance in any part of an image? The algorithm we use to do this is called E1, which uses Sobel operators to determine gradients. Gradients denote how much each pixel deviates from its neighboring pixels on the x and y directions. The first application we will discuss is image reduction. At each iteration of image reduction, we find the least important seam running across the image, either horizontally or vertically, and then we delete the seam. We repeat this over and over again, trying to alternate between horizontal and vertical seams. The result is an algorithm that reduces an image while being minimally intrusive upon the content itself. Next we will discuss image enlargement. Image enlargement is done by adding new unimportant seams to an image in either dimension. We do this by taking an unimportant seam in the existing image and creating a new seam in that location by averaging the values on either side of that image. We do this over and over again until we create a new enlarged image. In image reduction, we did this by iterating, and at each iteration we found a new unimportant seam to remove. We cannot do this with image enlargement. Because we are adding new unimportant seams, that approach would have the tendency of picking that same seam over and over again. Instead, we first reduce an image by n columns, or n rows. And then we remember those seams and use those seams to enlarge an image. With that, we have an algorithm that is minimally intrusive on the original image while enlarging it. Using our arsenal of reduction and enlargement, we can amplify an image or accentuate important parts of an image. We do this by first reducing the image to a certain size, and then enlarging it from that reduced image back to its original size, creating a more quote-unquote important or content-focused version of the original image. The fundamental algorithm for content-aware image resizing struggles with certain forms of content, such as human faces. We counteract this problem by marking these regions of interest, such as this woman's face, for preservation. Internally, we are artificially creating very high energy values in these regions so that seams will not cross them. By doing so, we can resize an image while not affecting the proportions of these regions of interest. We can also use this logic to remove objects from an image. While in preservation, we created very high energy values. Here, our special regions create very low energy values, so as to attract seams to cross through them. Here, we remove the bird in the upper right region of this image by marking it as a field of interest. Here's the final run-through of the applications discussed in this video. Here's the ocean image, amplified, enlarged, and reduced. Here's the image of birds, and the bird in the top right removed from the image. Here's the image of the woman, and here's the enlarged version of the image without warping to the face. Thank you very much.